Do a quick check if we
Yeah, it would be easier for them to
testing.
be easier. Is he sleeping?
Switch. Well, testing 1, 2, 3. Perfect. Good afternoon, everyone. Hope you all had a terrific lunch and welcome back. Let's go ahead and get started once again. I'd like to go ahead and introduce our next guest. His name is Jan Spacek, right over here. Without further ado, if we could welcome our guest to the podium. Thank you.
Oh, yeah. Okay. So, hello, everybody. My name is Jan Spacek, but feel free to pronounce it Jan Spacek or Jan Space K, which is even better. I will be talking about actually looking for life on Mars with heavy lift, which is the topic of this conference. And I will be talking about how we are trying to find life on Mars before humans arrive on Mars. We started an organization called Alpha Mars, and I'll be talking about that. So in my talk, you will find out how to find life based on unknown biochemistry. How do you find life with unknown ecology? And how do you do it when you have maybe 4, maybe 6 years to do it, very short periods? So Alpha Mars stands for Agnostic Life Finding Association Mars. For now, you can just say that it's alien life finding. You will understand later why it is agnostic. So our team, this is me. I'm a molecular biologist and electrochemist. Stephen Benner is the main finance supporter right now. He was speaking this morning, so he already introduced himself. He's I would say, a science generalist, specialist in chemistry, but made breakthrough discoveries in molecular biology as well. Victor Parro and Lyle White are world-class astrobiologists. Both are microbiologists specializing in extremophiles. Victor Parro is a director of Spanish Centro de Astrobiológica, and Lyle White is from McGill University. Shannon Butcher and Olivia Trankley, they are helping me right now to design the instrument. So I work in Florida, but for this project, I moved over to Eugene, Oregon. And I would mention one more person, Janusz Petkowski, which is Deputy Director of Venus Cloud Life mission, a mission which is sending, that's the first interplanetary mission. So he's helping with this project as well. The rest are students, postdocs who are helping us. We have Chris Tanby over here. So yeah, we are still a growing organization. So if you want to join, you can join us as well. So what was the motivation to start Alpha Mars? Well, to me, the more I know and the more we know about life on Earth and extremophiles, the more we are certain that there very likely is life on Mars. And surprisingly, although we are quite sure there is life on Mars, we have not sent missions to look for life on Mars since the Viking era. So this was the last mission. If sent to Earth poles or if sent to Atacama Desert, would be able to find life on Earth. So none of these missions, not even planned missions in the future, would be able to find life. And NASA Astrobiology currently predicts that we will return to looking for life on Mars in 2042 or in 40s, which means that we will likely have humans on Mars before we had a chance to look for life on Mars. Like all these missions, which say they are looking for life on Mars, they are looking for signs of past life, or they are looking for biosignatures. So yeah, NASA is not interested in looking for life on Mars. So in the morning, we had a presentation how we will return samples from Mars. I made this joke in April 1st last year, and it's turning to be less of a joke, as we are predicting to send humans to Mars long before we'll be able to return the samples from Mars. I'm looking if we have some people who understand Chinese in an audience, but yeah, never mind. So it seems that NASA astrobiology does not believe that anybody on Earth will be able to get to Mars before like 2050s. On one hand, everything we send to Mars or trying to bring from Mars has to be meticulously sterilized. And on the other hand, NASA does not plan to look for life on Mars before 2040s. So, and NASA itself plans to send humans to Mars. And know that humans cannot be autoclaved. So we have this discrepancy that up until year 2040, they are trying to not bring any bacteria to Mars or bring any bacteria back. But suddenly in 2040, we decide, oh, screw that. We didn't need to do that. So my personal analysis about sending humans to Mars before we know if Mars has active biosphere, while I believe it can be easily achievable. On one hand, it increases the sense of adventure. Don't get me wrong, I'm an adventurous guy. So I can understand why NASA is choosing this point of view. On the other hand, it's not very smart. I had it written in different words before, but I adjusted it a little bit. So why we don't want to work with NASA, why the Alpha Mars is private organization at this point. Stephen already mentioned the consensus approach in astrobiology before, so I'll just say that I find it very strange that National Academy of Sciences needs to tell NASA that the scientific process of multiple working hypotheses is the most rigorous and time-proven means by which to assess evidence and claims related to life detection. One would assume that NASA already knows that, but apparently they have to be reminded. Well, and perhaps over time, NASA will realize that it's a good idea to look for life on Mars before we have humans there. But as you know, there's not much time to wait. In standard NASA missions, it takes like 20 years from the conception of mission to execution. And right now we have maybe 6 years before, maybe 8 years before we have humans on Mars. So that's why we decided to start the organization Alpha Mars right now. Now for the positive motivation, the inspiration, that's the mission. I'm proud to announce that I'm a member of the team who is sending the Rocket Lab rocket to sample Venus atmosphere, not sample, to analyze Venus atmosphere using autofluorescent nephelometer, which is an instrument that shoots laser out of a little window and analyzes reflected or light or fluorescent light. And the laser wavelength was tuned based on experiments I've done with my student in Stephen Benner's lab last summer. So this mission will be verifying my hypothesis about organic carbon cycle in the Venus atmosphere. So because this is not Venus Society meeting, this is Mars Society meeting, I'll have just one slide about it, but I would be happy to talk about this with you if you ask me later on. Just one thing, this was important for me because I realized that not only NASA is able to do interplanetary missions, so we can do those privately. So we don't want to prevent anybody from going to Mars. If you can do it, go for it. But Alpha Mars want to make sure that by the time we are able to go, we know if there's biosphere on Mars. And of course, the instrument which I'm going to introduce a little bit later on, can be used when we have humans on Mars as well. So let's not postpone human missions to Mars after. we have astrobiological survey of Mars. We have to do it before we get there. So finally, to the scientific questions. How does Alpha Mars remain agnostic to our biochemistry? How do you find life that we don't know what is based on? So quiz for everybody in audience. How many of these do you think are made by life? And again, it's a trick question. None of them is. They are all false positive biosignatures. And many biosignatures are like these. That's why NASA Astrobiology proposed that consensus science, that when we see some biosignature, we need multiple biosignatures from the same location to signify that it actually comes from life and is not produced abiotically. But in some cases, it's clear with just single observation whether we detected life or not. And genetic polymers or polyelectrolytes are one of those examples. So genetic polymers cannot be produced abiotically. They must be produced by life. Well, they are actually required for life. And instead of looking for molecules that are produced, that might be produced by life, we are looking for molecules that are necessary for life existence. Without genetic polymers, you cannot have evolution, and without Darwinian evolution, you cannot have life in any form, including alien mind. So looking for genetic polymers, avoid false positive, such as methane or morphology I showed you on previous slide. It avoids false negative results. If you look for cellulose or some molecule which is common in Earth life and don't see it on Mars, it just might mean that Martians have not invented this kind of biochemistry. And genetic polymers must be either polyanions, like DNA in a life as we know it, or it can be polycations. Together they are polyelectrolytes, negative or positive charge in the backbone, and they have to have some information units which are similar shape and size. So that's why Alpha Mars approach is agnostic towards searching for life. As long as you find genetic polymer, you know that you found life. So how do we remain agnostic towards ecology? After all, we don't know what Martians prefer. There are many opposing ideas where we should send rovers to find life, if permitted by NASA, of course. We step aside this issue by sampling entire planet, and I'll explain how we do that. But for that, you need to understand how Martian climate changes over time. So right now, we are in a situation where Mars have a quite small obliquity. That's the tilt of the rotation axis, but it can get very low to very high obliquity. During that high obliquity, the ice and precipitated carbon dioxide sublimates, and then snow in mid latitudes. And then over summer, it's retained. So in high obliquity periods, you get Mars, which has a much thinner but larger in area polar caps. And those glaciers are staying in mid latitudes up to this day. So during that period like now, we have a small thick polar caps, low humidity, cold summers, and low atmospheric pressure. And the high obliquity period, it's in the reverse. And if such life, well, if such ice was on Earth, it would definitely contain life. So we can see the ice deposited from the last warm and moist period in these radar observations, and we can actually see when we have impacts, we can see the excavation of the ice laying very shallowly. Notice this is between 10 centimeters to less than 1 meter. So here's my lasagna ice hypothesis about how life is deposited in this mid-latitude ice, which we can see in this clip. Or, well, and now Martian life is basically waiting for the next warm period in the lasagna from which we can sample it. So, as I noted before, if you just sample one side, you can miss the life. That's why we decided to look for life in the lasagna ice, where it's deposited from the entire surface of the planet. Now we need to pre-concentrate because the life is going to be very much diluted, very likely. And also Mars is not very energy. There is not much energy for bacteria to use, so we expect life to be sparse. So we will need to sample very large samples. Because if you sample just 1 milliliter and life exists in like 10 bacteria per 1 liter, you might just miss the right milliliter. So the idea is, instead of sampling 1 milliliter, let's just sample 100 cubic meters. So the problem is solved by somebody giving us a sample of 100 cubic meters of Martian ice, and we can find life on Mars. But who should do it? And the answer is SpaceX or any other agency which is following Mars Direct architecture. Here I don't need to introduce Mars Direct, which is making propellant from local resources. But any ISRU can be used if whoever first mines ice on Mars can be the first to find life on Mars. So that's the goal of our mission. How the mining is going to be done? Very likely using these rod wells, where you make a hole, pump hot water in, melt some Martian ice, and pump it back, repeat. And ALF, the detection instrument, would be sitting on this pipe, analyzing the water before it is used. So notice that we are not proposing a separate mission, we are proposing add-on to existing missions. So if somebody plans to go to Mars, we can provide them with a means how to find life on Mars. So because first, before you go to Mars, you need to send those robotic missions. We are sure to have somebody sending those missions for us before sending the humans. Right. It's quite small instrument, consuming very small amount of energy compared to how much energy will be needed for refueling a rocket. And so finally, I'm getting to the technical side of the thing. Alpha Mars is ALF, which is the concentrator, and analyzers. So analyzers are already established. I'm not going to much detail because I'm running out of time. It will be mass spec, min ion, and other techniques which are already established on Earth. More about our approach that's based on using electrodialysis. If any one of you had a low sodium soy sauce, it was using the same method we are going to be using to extract genetic polymers on Mars. It's basically based on a quite simple approach. You have those greens are membranes with different size pores. So you pump in the middle stream feed of molecules. Negatively charged molecules are pulled towards anode, positively charged are pulled towards cathode, and then you separate them by size. So on Mars, we are going to do the same thing. Instead of soy sauce, we are going to be pumping ISRU water in and isolating, purifying, and desalting polyelectrolytes, polyanions, and polycations, which can be concentrated from a huge amount of Martian ice. So now I'm working with this team in Oregon. These people were helping me while I was in Florida. Instrument at this point looks like this. And on Monday, I managed to separate sulfate from sodium, making sulfuric acid and sodium hydroxide streams. I bet that next week I'll be able to separate food colorings, which are charged. And weeks after that, I plan to do some work with actual DNA. So milestones, before end of this year, I hope to have a working prototype in my hand. Then we will combine it with methods which already exist, and people are already waiting with the analyzers for our steps. Then those astrobiologists I mentioned in the beginning, they have access to Antarctic and high Arctic, so they will help us with establishing missions there to look for life. And then we will make automatization and miniaturization, work on space readiness, and we should be ready to send the thing to Mars by year 26. Well, we'll need help from you to achieve this. You can go to alphamars.org and you can, we will need some financing. We can join the project. You can help with the work. Publicity, and if you have contacts to people who are going to mine ice on Mars, that will be very helpful. So in summary, I am not going to do summary because I'm already over time. This site should be on very soon. Thank you for your attention. And
Thank you very much. Do we have any questions?
I'm wondering how agnostic your search for life is in what possibilities, if any, of you have excluded. So for example, the theoretical possibility of silicon-based life as opposed to carbon-based life, where do you draw the lines in terms of what you plan to look for?
So yeah, if life, so if that depends how you define life. If you believe that life is evolving, was not created, then it has to have some molecule which is replicated and which can mutate. And for that, you need polymer, which is charged with either polycation or polyanion. Stephen was talking about that in the morning, but I hope that this answers your question. I don't think that there will be silicon-based life anywhere because silicon is not very good for complex chemistry. So, but still, if there's silicon-based life, it would still have some backbone, some molecule which can be detected.
Can you clarify, is the goal to detect genetic polymers free in the environment as remnants of dead life, or is the idea to separate out the genetic polymers from extant life?
Yeah, I didn't have enough time to say that we are going to be sonicating the stream, and also DNA does not survive for more than about several million years when it's alone in the ice. So if we find DNA, for example, then it's quite likely that it's from recent past. It cannot be like a billion years ago, because by that time it would be totally decomposed.
Is that the case with all genetic polymers or just DNA?
Well, we know about DNA. Of course, I cannot give you a serious answer about polymers. I don't know, but yeah, some samples will be sent back as well. So yeah.
Thank you so much. Thank you so much. Right. I'd like to go ahead and introduce our next guest. Our next guest speaker actually comes to us virtually. Name is Miroslav Rozlosnik. I hope I'm saying that correctly. Are you with us?
Yes, hello. Can you hear me?
We can hear you just fine. Thank you.
Fantastic. Okay. Yeah. Thank you for giving me the opportunity to be here. It's really honor and my pleasure to be able to talk about underwater analog missions. I will try to start my presentation. Hopefully it will work. Can just someone confirm that you can see it in presenters mode? Hello, can you hear me?
Okay, it's still loading.
It's loading, okay, because yeah, it's somehow stuck in on my screen, so.
We're not seeing it. Yeah, we're not seeing it, unfortunately. Oh, there we go. Perfect. We got it
Here we
now.
go. Okay, excellent. Okay, so today I'm going to talk about underwater analog space missions. And yeah, it's my name is a little bit difficult, so I am fine if you just call me Miro, because yeah, it's a Slovak name, so it might be difficult for some people. Today I am going to talk on behalf of two organizations, on behalf of Hydronaut project, the project which is a unique project running underwater habitat in Czech Republic, and also on behalf of my diving school called Mironaut. Before I start, let me just introduce myself a little bit, because my road to space and analog space mission was not straightforward, and basically it started with diving. I'm a diver and I'm a scuba diving instructor, and I've been diving for more than 20 years. And this is basically where I gain all my expertise in hyperbaric medicine. From educational background, I'm environmental physiologist, but really hyperbaric medicine is something that really interests me. And such expertise in hyperbaric medicine, also being participant organizer of different expedition in really extreme conditions, basically brought me to analog space mission. I started with the toughest one, with the underwater ones, and then I moved to the surface-based ones. For example, last year I was flight planner at Amada 20 mission, and this year I also joined Habitat Marte virtual mission. So that's my part in analog space missions. But since we are talking about the Mars, I'm also involved in some Mars-related projects. In Slovakia, we have been running a special project which is focused on hybrid rocket engine, and this hybrid rocket engine is powered by VEX. So it's a VEX-based hybrid rocket engine. I'm involved in this research, in this development, and this August we had a beautiful. April we had a beautiful hot fire test, as you can see in the middle. This project is of course supported by European Space Agency. So, but let's jump into the space exploration. When we talk about the space exploration, of course, everybody is probably familiar with microgravity, with radiation, and all other factors. Of course, with all the technical difficulties we will need to solve. But most importantly, there is another additional challenge, and it's us. It's us human being in terms of psychology, as it was pointed out by several speakers today. There are just really few people who experience how it is to see Earth from the distance, how to see the Earth from the moon, and of course there was so far no one who was able to see the Earth from the Mars. And of course this kind of psychological changes are very difficult to predict how human being will behave in long term exposed to such situations. Of course, there are also some another risk associated, like remoteness, basically very limited ability for the rescue, and some other psychological factors. And in order to be able to address all of these psychological factors, we need to use those simulations, and really to be as efficient as possible. We need to do it in tough conditions. And one of the toughest environment where we can run analog space mission is underwater. And why it's so? It's because underwater we can really have a lot of similar features like we see in the space. Of course, underwater we can play with microgravity. We can adjust it as we need. We also need to create a whole system which is life support based, because such habitat is not possible to run without a proper life support system. Of course, it's also correlated with mission control. So all these factors very, very similar to the space exploration. Of course, what is also very unique on underwater space mission is that you can simulate a situation that you cannot access directly to surface. It's because in underwater analog space missions, you are usually using saturation diving, saturation technique, meaning that your body gets fully saturated, and it takes you need to basically undergo special kind of decompression procedure to get to the surface, which can last really hours up to the days. And of course, in underwater habitats, inherently, you have also elevated CO2 level, what obviously we are experiencing it on ISS, but also probably it will be experienced on Moon or Mars, or in Moon or Mars habitats. Currently, there are, to my knowledge, there are 3 operational underwater analogs or habitats. 2 of them are based in the United States. There are in seawater. One is as I said, in Czech Republic. It's called Hydronaut. It's based in sweet water, and also the main difference is that two ones in US are fixed, and the one in Czech Republic is mobile. It's mobile not only that it can be moved to another place, but you can also change the depth. And the depth is a factor because depth limits it creates demand for decompression. The one which is located in Florida called Jules, actually it's underwater lodge, but it was used for some analog space missions, is relatively shallow and doesn't require decompression. For example, Aquarius as well as in Florida, it's a little bit deeper and it requires really almost a day for decompression. Our Hydronaut is located currently at 7 to 9 meters of the depth, and it takes between a few hours up to 1 day to get to the surface. Of course, the size is also different. While both located in Florida are multi-compartments, the one in Czech Republic is single compartment. Yeah, how it looks like. So you can see the habitat on the right side of the screen. So basically the aquanauts, aquanauts are analog astronauts or people living underwater for more than 24 hours. So aquanauts live in a white chamber, white vessel. The diameter is relatively small, just like 5 meters long and 2.5 in diameter. It's fully equipped with all devices required for the proper research, so all Wi-Fi computers, sensors for environmental, atmosphere, and also some other parameters are present. And of course, the habitat is supported by motherboard, which you can see on the picture below, and basically it's a structure where you can find all life support systems. The whole project is at the prototype stage at the moment, and it is part of the Business Incubation Center of European Space Agency located in Prague. So there are also such activities related to European Space Agencies running. So how it looks like in the habitat. The habitat is entered from the bottom. So you can see such a manhole through which you get inside. The diameter is something like 90 centimeters, so you can fit with all your equipment to get inside. Once you are inside, on one side we have a living area where we have three beds actually at the moment, where we have a small kitchen, where we have also toilet. And opposite side we have a communication center with all the computer sensors, and also, as you can see on the right side, there is also greenhouse at the moment, which is used for some experiments. Of course, the whole habitat needs to be properly monitored, and it's monitored from the control center. Control center is located on surface, and we monitor both crew in terms of like visually monitor, so we have all cameras running, and of course we also monitor the inner atmosphere. And we also see inputs from all the sensors which are attached to the bodies of analog astronauts. So we can see, for example, like heart rate, breathing rate, temperature, etc. Of course, we also communicate with the aquanauts, and we can run different tests through our mission control center. Yeah, so far there were 3 missions executed inside the habitat. The first one was done in 2020. The mission scope was to show operationability of the habitat, so ability to live inside, and to divers, to aquanauts spent 7 days inside, and at the time it became also the Czech record for the longest dive. I had the pleasure that I joined the mission in 2021. The mission scope was different. The mission scope was focused on the science, so we did quite a lot of experiments, various kind of experiments, focused on microbiological contamination, telemedicine, psychological experiments, and also on decompression stress. At that time, we were a crew of 3 inside the habitat. The mission was a little bit shorter. It was planned to be for 2 days, but since the conditions were so harsh, it was a little bit shortened to keep the safety of us as aquanauts in a reasonable manner. Just to give you a perspective, so inside the habitat, we had 12 degrees Celsius or 53 Fahrenheit. But we had 100% humidity, and this was really harsh, and it was really not so easy to bear. So this was the main reason to shorten the mission, because at that time we needed to do wet decompression, so means that we needed to be inside the dry suits and to stay something like 2 hours in open water breathing oxygen, what is quite challenging. So these were all reasons to shorten it to be acceptable in terms of safety. Just a few pictures from the mission. We did a lot of experiments, physiological, biomedical. You can also see us with all the sensors and testing some telemedicine devices. In this case, it was a stethoscope, the remote stethoscope. We also performed AVA in a standard commercial setup. So with a hard helmet, and you can see the habitat is located in freshwater, so the freshwater visibility is usually not so good, and you can see at that time during AVA, which was dedicated for visual inspection of the habitat, visibility was something like 1.5 meter, so very, very, very difficult conditions. This year in August we had a mission which was called Diana 3, and this mission was focused on a lunar simulation. It was run by Department of Psychology of the Palacký University in Czech Republic and some other partners from different universities in the Czech Republic, and also from some companies. And the scope of this one was really purely psychological, and it was to create a tool for the best identification of the best psychological parameters for the future crews, and for monitoring the psychological well-being of the crew. And of course, this was not only focused on psychology, but it was also supported by physiological data. So now, at the moment, we are basically analyzing or correlating both psychological and physiological data out of this experiment. This experiment was a little bit more complex. Actually, we had the two habitats. One was located on surface. It's this floating container on the left side, and a hydronaut which was immersed in the water. Both crews were of the size of the tree, and they spent 7 days in pure isolation. So one on the surface served as orbital module, and the one in the depth in underwater was landing module. And of course, there had different roles and different tasks to be performed. The mission was very, very successful, and we also had a lot of reach out activities with the kids, different teleconferences, and I think we also ran the first intercontinental and intercontinental analog teleconference between hydronaut and between the habitat Marte. And of course, they were on surface or virtually. It was a virtual event, and we were underwater. So the mission lasted almost 170 hours, and everything ran smoothly. And also during this mission, we were able to develop a modified decompression schedule, which allowed at the moment to shorten the exposure in the water. So it's so-called semi-dry exposure. So just like maybe 5 to 10% are spent in the water. But of course, in future, we will target to have a pure surface, or let's say the dry decompression for divers. So what is the future? So at the moment, the habitat is going to be removed from the water. It's getting to be refurbished a little bit, and of course, to allow it for more prolonged missions, for more challenging missions, including also communication delays, for example. Also focus on maybe some in situ reutilization of gases or water or some other media. And of course, it's still ongoing process of optimizing the crew selection criteria, because at the moment we are using commercial divers or very highly trained divers. And this is basically my role, where I'm very active now. And it's development of the special aquanaut training for our purposes. So let's say the divers with some let's say medium experiences would be able to join such missions. Yeah, well, sorry. Well, yeah. So yeah, so that's it from my end. I thank you again for giving me the opportunity to talk about our mission. And I also encourage everyone who is interested in underwater analog space mission. So you can join my LinkedIn webpage dedicated to underwater analog missions, which is called Mironaut, or you can reach out to me on the social media. And I'm
Very good.
ready
Well,
for your questions. Yeah.
Yes, we have one question here in the audience.
Yeah.
Hi, thank you for that. I appreciate that. I have that we've had somewhere around 80 or 90 years of submarine operations and people living and for extended periods of time underwater, civilian and military, around the world, actually. How is it that, well, assuming you do, how is it you incorporate lots and lots of that data, psychological, physiological stuff? How is it? We just deal with that, please.
Yeah, well, unfortunately, you know, I'm from Slovakia, and we don't have a submarine or a navy, so for me it's a little difficult to get to this data. And to be honest, I'm not. I know that there are a lot of studies done on the people living in submarines, on the divers, on the crews, but to be honest, I'm not sure whether there was any kind of comparative study done between, let's say, the saturation divers and submariners. These I really don't know.
Do we have any other questions in the audience? Got one more question over here.
Interesting presentation. Thank you. I've got a question for the aquanauts when they're on EVA. How is real-time communications done? And if it's not, what do you have plans for in the future?
Yeah, so during the AVAs, basically the diver is connected to the habitat via umbilical. So yeah, all the media like electricity, video, or breathing gases is transmitted via this umbilical. So, and also communication in this case, considering let's say the safety and circumstances is real time.
Do we have any other questions here in the audience? No. All right. Thank you, Miro, for your presentation, and appreciate your time. Thank you very much.
Yeah.
Looks like
thank
we
you
have a
very
few
much.
more minutes. Thank you. It looks like we have a few more minutes until our next guest speaker. So give us about 5 more minutes and we'll get that started for you guys. Okay. Thank you.
Check, check, check.
Sorry, I can hear you. Let me check something.
Sure. Can you hear me
Okay.
now, Jacek?
Yes, yes.
Unmute the Zoom. Mute the Q&A mic and unmute the Zoom.
Can you hear me?
Yes, now we can hear you.
Okay, great.
Nice to see you, my friend.
Nice to see you. So I guess we'll start in 5 minutes.
That's right. Do you want to go ahead and share your slides? Make sure that's working okay.
Yeah, just a second. Okay. Share screen. Okay, I think I got it. Can
Okay,
you see?
yeah, we're looking good on this end.
Okay. So let me know when we are ready. I'll just mute my phone, just in case.
Yeah, it's you have 3 minutes and then you can start whenever you're ready. Okay. And so 3
After the
minutes
3
is your
minutes?
time.
Okay.
3 minutes from now is your time and you can start at that point whenever you're ready. Thank you.
Okay, thanks. Just a small question. Do you see my aside from my presentation, do you also see the opened window here? Because I will need this.
Yes, we sure can.
Okay, okay, great. So I can start in 2 minutes, I guess.
And that's totally up to you. If you'd like to go ahead and start right now, that's
Okay,
go
so
ahead and get started. And yes, ladies and gentlemen, I'd like to go ahead and introduce our next speaker, Jacek Wyszynski. Jacek, if you wouldn't mind taking it over,
yeah,
go ahead and get started.
yes. So hi everyone, it's great to be here. Today I want to show you the progress of our project Occupy Mars the Game, which we are working on since 2017, so like many years now. But a lot has changed since last year, so I wanted to update you guys and show you what we have changed, what are our plans, and some exciting things which we figured out while working on the game. So first of all, thank you very much for inviting me again to the panel. I'm extremely happy to be a part of this conference, and also that I'm a member of Mars Society. And we've been working with Mars Society for a few years now. We cooperated with the Mars VR Kickstarter campaign. We also made the YouTube mini-series Diving from Mars. Some videos with James Burke and other people. We shown the Mars Desert Research Station and the Arctic Station. So we love the fact that we have this great cooperation, and we want to contribute as much as we can. So thanks again for inviting me. And now I will do a quick introduction of our studio, some of the history of how we started working on the game. And then I will show you the cool stuff. Okay, so first company introduction. We are Pyramid Games. We are from Lublin, Poland, European Union. We were actually founded in 2010. First, we were working on smaller games, mobile games. Later, we started working on PC games, and in 2017 we started working on Occupy Mars. Meanwhile, we released Rover Mechanics Simulator, which is a very detailed simulator of the rovers which are now on Mars, where by playing the game you can learn a lot of the details about the scientific instruments which are on board the rovers, while also like having a relaxing experience. Another game we released is also like educational and scientific, called Dinosaur Fossil Hunter. It's a paleontology simulator where we explore the topic of paleontology. And the biggest upcoming game is Occupy Mars, of course. That's why we are here. Here are some links to our social media if you're interested. And yeah, how it actually started. Like here, I want to show how my adventure with Mars started. So actually, it was in 1997 when Sojourner was landing on Mars, the Pathfinder mission. And in 1997, I was 9 years old, and I was on vacation with my parents, actually in Wrocław, capital of Silesia. And this is the year where so-called the flood of the millennium happened. So if some of you are following Netflix, there is this hot TV series right now released by Netflix called High Water. It shows the story of the events that happened exactly at the time. So in Wrocław in 1997, the biggest flood, and this show turned out to be quite popular right now. And actually, I was in the middle of this situation there because we were on vacation. I was not 9 years old, and instead of worrying and watching all the drama and evacuations in the news and outside, I was only thinking about the fact that the Pathfinder mission is approaching Mars, and I was focusing on watching the transmission from landing. And I was doing this with great excitement. I was very little back then. And next day we had to evacuate as our hotel became flooded, and we were walking in like very deep water, trying to reach the evacuation bus. So basically what this TV series show happened to me when I was little, but I was just thinking about sojourner landing, and I remember this situation completely differently. And yeah, so this was like my start with Mars. Later, as a computer science student, around 2008, I was also working on a Mars game in a computer science club. So it's supposed to be a strategy game, smaller one, but this was when the dream about Occupy Mars the game started. Yeah, so now I want to tell you about the timeline for those who didn't know us. So like I said, the first game prototype was actually 2008 when I was at the university. That was a long time ago. Then in 2010, we started the company. And in 2017, we started the production of Occupy Mars the game. Meanwhile, in 2020, we released Rover Mechanic Simulator and Occupy Mars demo and prologue. And right now, we are very close to releasing early access release of the full game. And also we are running the beta version right now. So the community members can play with us and help us find bugs. So now I will show you how it looked then and how it looks now. So why it was so important for us to develop this game for many years, because you can see the progress very clearly. This is, for example, some versions from 2017 probably with the spectral detector tool, and how it looks, how it looked then is on the left, and how it looks right now is on the right. So as you can see, everything changed. All the quality of models, terrain system, environment, even weather, the HUD in the helmet, everything. And there were many iterations. So here, how the rock mining looked in the rover back then in 2017-19, how it looks right now with the tessellated terrain and the landscape. Here, for example, one of the things which we wanted to be accurate, so-called blue sunsets, which happen on Mars. And so the left image from early development days shows we didn't have that yet, but the blue sunsets are in the game and they need to be, because they are beautiful. Yeah, so here is our tablet, which is the main place where a player is getting all the messages and keeps track of his game. So right now you can customize it with a logo which you want. So you can put a Mars Society logo or any other logo here, and it's much more easy to use right now. Yeah, so this was the short story of the development and why we work on this game for so long, because yeah, we want it to be the best. And meanwhile, we released Rover Mechanic Simulator, as I said before, a smaller game which focuses on fixing the very detailed Mars rovers, which we did all from scratch. And we released it since then on Steam, Switch, Xbox, and PlayStation consoles. So we wanted to give something to our fans who are waiting for Occupy Mars the game before we release the actual Occupy Mars game, because it was taking us longer than expected. That's why Rover Mechanic happened. And here's some screenshots from the game. As you can see, there's so many details. You can learn about every screw, basically every part. This is, for example, from Opportunity wheel, what is it made of. And the game turned out to be really well received. 90% very positive reviews, over 28,000 copies sold to this day, without the bundles and humble bundles. Launched on Steam in February 2020. And then we had a full release after early access. And thanks to this game, we are also cooperating with European Rover Challenge organizers for many years. Since 2019, basically, we are co-organizing the Rover Mechanic Challenge online event, which is like expanding the main event. And then now we switch to the main topic. So Occupy Mars the game is a highly technical, realistic open-world sandbox survival simulation game about Mars colonization. So in the game, you can, this is like a short introduction, so you can build and upgrade your base, discover new regions, conduct mining operations, retrieve water, generate oxygen, grow crops, fix broken parts, and learn how to survive on Mars. But actually, you can do many more things in the game than this short description. And I will show you some screenshots, but I wanted now to show you a video, our work in progress trailer of the game, how it looks like now. right now. It's not yet final, but I think you will enjoy it. So it's like first time we are showing it. So yeah, and just let me launch it. And I'm not sure if you will hear the music. I hope you will from the trailer while sharing the screen. This. Okay.
Cannot hear the sound, Jacek.
So without the music, right?
Probably need to stop and reshare and make sure the share computer sound checkbox is checked on Zoom.
Okay, you think it's possible? I'll try. Advanced sharing options.
I would totally stop sharing your screen and then reshare
Okay.
with that checkbox checked.
Of course, I can show it without music, but it's all better with the music. Okay, so stop sharing. Oh yeah, there is an option. Share sound.
Fix it.
Great. Okay, so I will restart it and let me know if you hear it.
We still don't hear it.
Still don't, right?
Correct. We
because-
still do not hear it.
Maybe it was just too quiet. Let me try again.
Negative. We still do not hear it.
Okay, I'm not sure if this will work, but I have this indication that I'm sharing the sound from the computer. So maybe I will just move on. Okay.
If you send me the link to this video after the conference, I'll make sure it's in the YouTube archive for you.
Yes. Okay. Sure. I will try one more thing, switching microphones to system. Let's see.
Okay. Negatives. It's amazing. It's amazing. Hearing a little bit, maybe it's just really low when you're in somewhere.
Okay, so that was the trailer. I will send later the link, so maybe you can add this to the video later. Now I guess don't have much time, so I will speed up. Now we have the profile creator where you can create your own astronaut. You can select his arm patch. You can basically select everything about his look. Yeah, so some screenshots from the game. So we also added dust devils, tornadoes, and they are, the player can select how intensive are the weather effects. Sometimes you can select them to be like this, that all the time something is happening and you have to really work hard to survive. Yeah, so some growing crops. We have many different species of crops which you can grow to eat food or to produce oxygen. And so key pillars of the game are base building, exploration, and survival. So basically, player is one of the first colonists on Mars. It's in the future, but it's close future. And he needs to build base from multiple interconnected buildings, sections like something like ISS, because we researched that and we decided that at first, of course, later in the colonization effort, the bases will probably be underground, but at first we will probably build something like the ISS, so modular buildings, and this is what the game is focusing on. Exploration is because we have implemented real-life Mars locations based on some NASA heat maps, but also the terrain is procedural and basically unlimited. So between the locations which are known, like Gale Crater, Korolev Crater, Jezero Crater, Olympus Mons, Valles Marineris, there are also some other places which are generated, and it creates the whole planet as we want it to explore it. And survival elements is one of the most important aspects of the game, because there is 100 different ways to die in this game. You need to control your oxygen level, hydration, nutrition, stamina, your pulse, and overall health. And there are many dangers in the Martian environment which can kill you, like solar storms, tornadoes, dust devils. Meteor showers can happen. Radiation is a big problem. You have to also think about cold waves, cold nights, cold winters. Of course, sandstorms are the most problematic because they prevent us from generating electricity. Yeah, so that's why survival is very important. Base building is basically the cool aspect of the game, where you can design your own base as much as you want, and the way to design it in a way that you can support life for many colonists, which then will be living here. So while working on the game, we had some interesting findings, like the scientific aspect of the game. So we tried to find solutions to the problems which might be encountered while building first real Mars colony. And so the questions we asked, like, what are the most needed tools on Mars? What's most important for survival? And also we had to think about how to balance realism and fun in the game. So as I said before, the buildings need to be modular, and they have cables and pipes in the floor, so it's very easy to interconnect them. Radiation shielding in walls, and in the game we describe the electromagnetic fields in the walls of buildings which help mitigate some radiation. And personal living quarters are connected by corridors for so you can easily visit others. And there are also common spaces like cantina where everybody's eating, or like this 2-floor HQ with a workshop on top, greenhouses and domes for plant cultivation. And also we need universal airlocks and great insulation glass. And the crucial tools on Mars are seen in the screen. So this is like a landing capsule for the Pioneer astronaut who who wouldn't land with the giant rocket, but in this case, he's landing in a small capsule, and he's got only the basic tools, and he needs to figure out how to survive and build the base. So here we can see a grinder for destroying buildings and retrieving resources. The drill on the right is for extracting resources from rocks. We have the plant seed tool for putting plants, spectral detector for checking what type of minerals are in each rock, and also finding water spots where wells can be built. With wells need to have heating, of course. Welder is the most important tool because it allows you to build stuff, weld metal. There is also a new tool called air pressure tool for cleaning up solar panels with compressed CO2. And also the compressed CO2 is a byproduct from the Sabatier reactor, which helps us produce oxygen and methane. So we try to use every resource we can have in the game, even those, like for example, methane first can be just flowing up into the air, but later we can store it in the tanks and use it for example, as another resource. We have, of course, fire extinguisher because fires can happen inside bases and they cause a lot of problems. A jetpack and basically the backpack of the player, pipes and cables, which are also heated, and universal. So all the sockets on Mars should be universal, like universal electricity socket, universal like water, oxygen, because it would be very like problematic if you would die because you had a different USB port or something. So it really needs to be everything needs to be standardized. Vehicles, of course, all vehicles must be electric. Heavy rover is like a mobile living quarter because it's pressurized inside. It has oxygen and power storage. It has fast airlock for getting out, and detachable trailers. So we have many different trailers. You can haul, for example, oxygen in the trailer, or you can have a trailer for rocks for extracting resources from the planet. ATV is for fast travel around the base. We call it quad. And we also added recently pickup truck, which is lighter and faster than the heavy rover. It's better for short trips, but it doesn't have bed or bathroom inside. But it also seats freer for astronauts, so it's better for like traveling in groups. Utilities. So as I said, it's crucial to have universal sockets, elastic pipes with heating, high-performance oxygen generators, universal cables, dense energy storage, redundancy anywhere you can, and water extractors. And the psychology aspect is also very important. As we know, isolation is very dangerous. We get less sunlight on Mars. There is high probability of getting depression. And also we can be, we need supplementation of vitamins and minerals, which, for example, we cannot have meat unless we bring it with us at first. So we have hydroponic plant cultivation. Later we can have aquaponics, so we would have fish, and that's good. But still, supplementation would be needed, and also robotic companions can help with loneliness. So that's why we added this robot dog, which we call Spotty. And he is a companion which helps the player with many different tasks, but also prevents from this feeling of loneliness. And you also need to have lightweight, high mobility spacesuit, which you can rely on, because this is the only thing which separates you from vacuum and from death, basically. So if you take off your helmet outside, or if you forgot to put in your helmet on while going out in this game, you will die without the helmet on. So, and some survival aspects. So just quickly, I wanted to point out what we have here. So as I said before, we have base life parameters. like health, stamina, oxygen, hunger, hydration, pulse, temperature, radiation, sleep. Every of this parameter, if it goes down, then you have a problem and you need to fix it. PCBs and repairing, because on Mars a lot of things have to be repaired by you, because you cannot just send it back to the factory or like. So you have to learn electronic soldering, fixing electronic equipment, and this is a huge part of this game. Every vehicle and every building basically have a PCB inside, which even if your vehicle is not damaged, but your PCB can fry, for example, due to radiation or something else, you have to take it out and fix it with your soldering iron on the workbench. Growing plants, so you can build greenhouses, oxygen tanks, hydroponic shelves, connecting all the pipes and cables, domes for like where you can basically create a garden, grow your own food and oxygen producing crops. Conducting experiments, so it's chemistry laboratory. This is one, the chemistry lab is still in progress, so probably it will be added as an update later. So vehicles, I already mentioned ATV quad, Mars truck and heavy rover, but we also have a motocross, like, because we also want to add some fun for the players. So not only realism, but also some fun. So we also have the jetpack, which you can, at the end of the game, basically you can have a jetpack and fly around. Because we are thinking, what would we do if we would live on Mars? We would want to do something cool, right? Like low gravity flying. So that's why we added this. We also added rovers from the rover mechanics simulator, like Spirit, Opportunity, Curiosity, Perseverance, and you can find them in the exact places where they are sitting on Mars. So it's like a hint for people who love rovers. And yeah, as I said before, we have real life Mars locations based on NASA data, and also we added some caves. So there is now a cave system, so you can also explore caves and find some unique resources in the caves. And the weather events, which I mentioned before, which are dangerous for the player. So as for development goes, currently we have divided our team basically into 9 different teams. Because it was too many. If everybody would be on the meeting every day, they would take too long. So now we have a core team, campaign team, bug fixing team, design team, co-op team. It's like something which we were working on undercover for some time, but the co-op team will probably be growing after early access release. And we want to add the multiplayer co-op as an update in the future. Of course, we have a testing team. Our great testers are finding the bugs as fast as they can. 2D team, so for some textures, we also created an art book and comic book for like an expanded version of the game. Support team, so like a project manager and graphics team, people who work on 3D models. So far, we had over 380,000 prologue and demo downloads on Steam. The prologue was released in 2020, and right now we have over 260,000 players on Steam wishlists waiting for the game. We hope it will only grow from now. And the game is, as I mentioned, in development since 2017. We also started working on the co-op technology, and we hope the game will launch pretty soon on Steam, Epic, and GOG simultaneously. We also produced that Tidebeam from Mars YouTube series to show more fun stuff about how to live on Mars and about analog Mars bases, and comparing that to our game, how it works in the game and how it works in real life in the analog bases. So the Tidebeam from Mars series is here. You can scan the QR code and watch it. We have 7 episodes for now, and we have at least 3 more in production. So it will be like a full season of 10 episodes total. And that's not all, because we have one more thing. I think it's first time we're showing an addition to the game, which is the mobile strategy game Occupy Mars Colony Builder, which we hope to release on Google Play and App Store for mobile, like together with the PC game, for players who prefer playing on the phone. It's a completely different game, but in the same universe of Occupy Mars. So here you can design bases. I have a very quick video to show how it works, like in a sped up version of it. So I will. Yeah, so I'm not sure if you had sound, but at the end of the video, you could see that you can also visit other players' bases and see how they are doing. And at the beginning of the video, there was a sped up tutorial shown where a player is learning how to build specific buildings and how to play the game. So this is like something which we are also very excited about, and we want to show all of that pretty soon and give it to the players. And one more thing is that we are preparing to launch a Kickstarter of our game and basically our universe, which we hope will help us gather some additional funding for the final push of the development. So because the game is in production for 5 years now, over 5 years. So this slight push at the end would be very helpful. And also the main reason for Kickstarter is that we want to reach more people who haven't heard about our game yet. There's a lot of users on Kickstarter, a lot of people who back different games, different projects. So we also hope that they will get interested in our game this way. Because of course, it's very important for the future of the game, and so that we can develop it for many years after release, then the launch is very important. So the more people know about the game during the launch, the bigger hope we have that the game can be growing and growing and keep living after the release. So that's my main goal, and that's why we were working on the game for so long. So that's mostly it. I was trying to talk pretty fast because I know our time is limited. And yeah, James, what do you think?
Yeah, we have time for a question or two.
Great.
Are there any questions in the room here?
I can see there is some Q&A. Okay, there was a chat.
Yeah,
somebody
so
wrote that they can hear the music, so that's great. Okay. And the question.
I'm showing the question from Carly Short in the Q&A panel on the screen there.
Yeah.
Do you see that?
Hi there. Yes. Hi there. I'm in the test play for Occupy Mars at the moment. How deeply are you going to go into the growing of plants in the future? The growing of plants so far seems like basic compared to other aspects. I'm not sure if this is just because it's early development. I'm enjoying what I've played so far. Yeah. So I hope that we will, of course, expand it, but I think the important thing is that in the beta version we are not showing everything. It's like a cut-out version of the game. So, for example, in the beta version there are no dawns for replanting. So, for example, if you are growing something bigger like an apple tree, you first have to put. Basically, there are multiple steps. So first you use the seed incubator to prepare your seed for growing. Then you put it in the seedling, like incubator wedge, where you you go from tiny seed to the seedling. Then you replant the seedling into the hydroponic shelves. You have to set up the correct light and the correct amount of water, because each plant needs different amounts of water and light, and also some plants require nitrogen. which is also harder to get. But this is another interesting thing that in the base we have toilets, and you can take out the fertilizer box from the toilet basically and process it in the special tool in the greenhouse. And then the waste tank is turned into fertilizer needed by some plants. Then after the plant grows, for example, like half a meter, you can replant it to the fields. And in the fields, they can grow to like 2 meters high. And then if you want to have something bigger, like for example, spruce or apple tree, then you have to replant it from the fields to the domes, which are higher, or those glass, big glass domes, and then you can have a garden in there. So I wouldn't say the growing plants is basic. I would say that maybe it's not easy to understand, and also it's not fully shown in the beta version because we don't have domes in the beta. Some devices for generating the nutrition are not enabled in the beta. So, but we are also always open for the feedback. We have a lot of ideas for expanding it, and also that's another reason why we want to do Kickstarter, because we can have multiple levels of campaign goals. So if we reach another goal, for example, we can have like autonomous drones, which will collect rocks for you and turn them into resources. Or, for example, we can have some people asked for wind turbines and many more devices for generating electricity aside from solar panels and nuclear. So this also can be another campaign goal of the Kickstarter campaign. So the same with plants and other things. For example, I would love to add the aquaponics, so having fish on Mars. This also is a great idea for the stretch goal of Kickstarter. So yeah, that's my answer. I hope you are satisfied.
Awesome. Thank you so much, Jacek. We have one more question in the audience here.
Okay.
Maybe I missed this, but what is the political and economic system that the game is supporting?
Yeah, so that's also very interesting. And this is something that will become important after we add the cooperation mode, multiplier mode, which we plan to add about a year after the initial release, because then we will have multiple players. Right now, maybe I can spoil a little bit of information that in the campaign mode, we have like a base, like one of the first bases, the bigger ones, not like the base for 1 or 2 scientists, but like for 50 people or something. And in this base, we have a governor. So basically, it's a governor who is like democratically chosen by the inhabitants of the base. And I hope that in the future, after we add the multiplier mode, it would be great to allow players to choose how they want to organize the political system and economic system, basically. Because at this stage, most of the time, player fights for his own survival. So he doesn't have too much time to think about, organizing the bigger communities in the game. This is something we want to add also as an update in the future. But this topic is, of course, very interesting, and I'm also curious what will happen after players will be able to play together in the game.
Thank you so much, Jacek.
Thank you very much. Do we have any more questions?
All righty. Thank you so much. So that's our last talk of the afternoon in this room. We're actually going to shut this down to prepare for Peter back at 3 o'clock. So for those of you here in the room, you're welcome to stay, but there won't be a talk for about 20 minutes or so. And for those of you online on the webinar, we're going to go ahead and end this, and you can join the next talk, Peter back at 3 o'clock using Zoom Events lobby. Thanks again, JSEC. The game looks amazing. I can't wait to play it myself. Thank you.
Thank you very much.
Take care, my friend.
Thanks. Bye.